More evidence that dark energy is weakening. Cosmic rays could keep life alive under the ice. NASA is building fuel depots in space. And a radio telescope is going to the far side of the moon. All this and more in this week's Space Buds. In 1998, astronomers were measuring the distances to various Type 1a supernova, which are considered a standard candle, to try and measure the expansion rate of the universe. And they discovered that the universe was expanding faster than it had expected. And this led to the announcement or the discovery of dark energy. And that led to Nobel Prizes all around. And still, people use Type 1a supernova to measure the expansion rate of the universe and try to calculate how dark energy is going to unfold over time. But one of the problems with all of those supernovae is that they were taken with different telescopes, different times of the year, different seeing conditions from space, from the ground, and that it's really hard to make really accurate measurements of the amount of dark energy in the universe when you've got such complicated, non-normalized data. Well, astronomers have gone and taken 2,000 of the best supernova discoveries and normalized them. They've gone very carefully, very painstakingly to make it as if these were all seen with the same instrument so that you can really compare apples to apples. And what they found really holds up this story that is starting to unfold, that the strength, the amount of dark energy coming into the universe has not been stable over time, that it seems to be decreasing. What was assumed was that dark energy was some kind of cosmological constant, that for every new cubic meter of space that you got a set amount of energy that was then entering into the universe. The more space opens up, the more energy that you get. What seems to be happening is that the amount of additional energy that you're getting with every new cubic meter of space is slightly decreasing. And this was the original finding that was made by the DESI survey, which we've talked about a couple of times in the last couple of months. And so you've got this other data point that is showing that this does seem to be what astronomers are detecting. But we wanted to use this story because it's 2,000 supernovae, and that is the best supernovae seen by astronomers over the last 30 plus years. Well, Vera Rubin, now coming online in just a couple of months from now, it's expected in its 10 years of operation to find 1 million more of these Type 1a supernova. So this is one of these stories that we're now about to get this huge flood of data that's going to help us answer this question. And we will know, is dark energy constant or is it fluctuating over time? And if so, when did this kick in? And what are the underlying mechanisms that could be causing this? And we've got a story by Mark Thompson on Universe Today if you want to learn more about that. The search for life is all about the search for water. Wherever we find liquid water here on Earth, we find life. And so it's assumed that wherever we would find liquid water out in space, that you would find life as well. But the problem is that you also need energy. On the surface of the Earth, not only do we have liquid water, but we have sunlight, and that's what allows life to flourish. But then scientists discovered that there was another place where you could have life, not dependent on sun. These are in the deep sea thermal vents, where you've got volcanic activity on the bottoms of the oceans. You've got areas where hot water is coming into the ocean. You've got chemicals that are useful for life, and you have ecosystems that have never seen the sun. They don't need the sun. And this has been exciting because there are places where there's liquid water, but people couldn't figure out how they would be able to get the kind of energy that they would need for life and chemicals. There could be deep sea thermal vents on Enceladus and Europa. And now a new study is proposing another place that we could search, a new habitable zone. And this is very exciting because it's very accessible. They propose that cosmic rays, which are considered to be one of the most dangerous things, one of the biggest hazards to spaceflight, could actually be keeping life alive and providing an environment. So these cosmic rays, they're generated by all kinds of extremely energetic events. Pulsars, supernovae, colliding neutron stars, supermassive black holes. When these particles strike your DNA, they can blast them apart and you can get radiation damage and even get cancer down the road. But when they strike the ice on the surface of a world like Europa or Enceladus, they can then break up and free electrons into this area. If there is liquid water in this area that has been melted and just under the surface, now you're producing energy that is going into this liquid water. And this could serve as a basis for another ecosystem. And you've got this around the entire surface of a place like Europa or Enceladus. And so if you wanted to be able to confirm this, you would just have to be able to do a lander, dig into the surface ice and see if you can find the free energy, but also maybe some kind of bacterial life there. And this also might be on Mars as well, on the surface at the ice caps. So we've got a huge new area that we can search for life in the solar system. And we've got a story about that by Carolyn Collins Peterson. Orbital refueling is the holy grail of spaceflight. Imagine that you don't have to carry all of your fuel up from the surface of the Earth. You can mine your fuel in space and then you can store it in repositories, fuel depots that you could then go and refuel your spacecraft and go on and carry on new missions. But the problem is that space is a very harsh environment, especially on the kinds of fuel that we use as rocket propellants. First, think about the kinds of propellants that we use. Liquid hydrogen, liquid oxygen, methane. But with liquid hydrogen and liquid oxygen, for example, you've got to keep them extremely cold in this condition where they're getting a lot of sunlight. Now you would think that because space is so cold, warming things up is the problem, but in fact it's the opposite. It's actually really hard to get rid of your heat. And so if you're in sunlight, which a fuel depot that's orbiting around the Earth or around the moon would be, then you're going to be receiving constant sunlight, and that's going to be heating up your spacecraft. And then that's going to heat up your propellants. And this is going to cause you a problem, like an explosion problem if you don't deal with this. Now, the traditional ideas for building a fuel depot is that you either make the fuel depot larger than you need so that as the spacecraft gets heated up, then the propellants can fill the volume as they boil a little bit, or you have a way to boil off your excess propellant. But that's terrible because you're losing fuel to space. So NASA is actually working on a zero boil fuel depot. This is a two-stage active cooling system where there are tubes around the fuel tank that contain helium that is cooled to minus 254 Celsius. That is cold enough that it keeps your hydrogen liquid, but it's just above the boiling point for helium. So the helium can stay as a gas as it moves around in this area. And then they use convection to extract heat from the liquid hydrogen and oxygen and then transfer that to a heat sink that can then radiate that heat off into space. And then you can maintain this system in the cycle over time so that you don't have to potentially lose some of your propellant. And so NASA is actually testing out this technology at the Marshall Space Flight Center right now, and we could see something like this fly as a test in the coming years. We've got a story about that by Andy Thomaswick. Lava tubes are one of the most exciting places on the moon and Mars. These are areas where there were volcanic eruptions in the past. And so you had some kind of lava flow across the surface of the moon, and then the surface solidified, but the lava was still flowing underneath. And then the lava flowed out onto the surface and you're left with this giant chamber. We have these on Earth and we have them on the moon and Mars. Well, how do we know? Because we can see the collapsed skylights from space where the ceiling of one of these lava tubes has collapsed. You can see the floor below. And these are ideal places to explore on both the moon and Mars because you've got a place that is protected from the radiation, that has a much more regular temperature inside and could hold geologic evidence of the past. And even on Mars, there could be the potential of evidence of life in the past on Mars. And so finding these lava tubes is very, very important. And there have been hundreds found, these skylights on the surface of the moon. And now researchers have built a machine learning algorithm to find many more. They took existing data that was really well understood, that they had a lot of lava tubes identified on the surface of the moon. And then they fed it new areas that the system had never seen before. And it identified several new lava tubes that had never been seen, essentially hiding in plain sight, that they were able to confirm. And that was only with about 2% of the surface area of the regions where there was lava flowing in the past. And so you can imagine they'll scale this up and be able to scan the entire surface of the moon and try and find all of the lava tubes. And so once you've done that, then you can examine and compare them with various criteria to figure out which is the one that we should be exploring first. We've got a story about that by Lawrence Tognetti. Speaking of the moon, the main theory for how we got the moon is that a Mars-sized object crashed into the Earth about 4.5 million years ago. That object has been called Theia. And the shrapnel, the wreckage of that explosion, coalesced into the moon. And then, in theory, it cooled down, the surface solidified, the lava flows on the surface stopped, and now we see the moon today, which is like this fossil of what was once a much more active world. And it was assumed that this volcanic activity on its surface ceased just a few hundred million years after the moon formed. But the Chinese Chang'e 5 mission brought back samples to Earth from the moon that showed that some of the regions where it was sampling, there had been volcanic activity as recently as 2 billion years ago, which is long after it's expected that the volcano ceased on the surface of the moon. And so what's interesting is that the region where this was happening is very rich in uranium and other radioactive elements. And so the researchers think that the decaying heat from various radioactive materials in the area kept surface magma molten for much longer, so you could get volcanoes acting on the surface of the moon for a much longer time. We've got a story about that by Matt Williams. We've talked many times about how the far side of the moon is the ideal place to put a radio telescope. Once you get all of that moon in front of your radio telescope, you block all of the pesky radio interference that's coming from the Earth, all of our broadcasts, all of our air traffic control systems. All of that is just shielded, and you've got this clear, beautiful view to the cosmos. And there are very specific wavelengths of radio waves that astronomers are hoping to get more information about. One of these is known as the dark ages of the universe. This is a time when the universe was dark. The galaxies had yet to form, their light had yet to clear away the space in between, and it's a very hard time to study. But there are clouds of cold hydrogen gas that early on in the universe. And those give off a very specific signal called the 21 centimeter line. And that line of radiation has then been redshifted, and so now appears as radio waves almost 13.7 billion years later. And so astronomers really want to put a radio telescope on the far side of the moon. And like I said, I've done tons of stories about this. I've interviewed tons of people about this. This is going to happen. But now there is a mission that is being built to actually try this out. And the mission is called Lucy Night, the Lunar Surface Electromagnetics Experiment Night. And this is going to be a radio telescope on a Blue Ghost lander. And if that name sounds familiar, that was the Firefly lander that successfully touched down on the surface of the moon. I know it sounds really weird, but a spacecraft landed on the moon and everything was fine. And so based on that, it seems like it's a very successful platform and the perfect place to put a radio telescope. And in the development of this radio telescope, they had about 150 kilograms to work with. And the astronomers wanted to be able to have this telescope operating for a long period of time, for years. And of course, one of the big challenges that we've talked about, you get 14 days in the sun, and then the lunar night sets in, and that generally kills all of the spacecraft, kills the batteries. And so to get through this situation, they designed a new thermal system that allows it to switch from it's in full sunlight to it's in total darkness and the temperature is very, very cold. But they also put a gigantic battery to go along with this mission. It's a 50 kilogram battery that can store enough energy to get through 14 days of darkness to be able to keep itself warm and then be able to power the radio telescope through that period as well. And so they had to give up a third of the mass, and yet they were still able to make it all fit. And now they've got what will be a radio telescope that should be able to survive for many, many cycles on the surface of the moon. And this is going to fly on an upcoming Blue Ghost mission. We've got a story about that by Andy Thomaswick. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week was the discovery of a companion star for Betelgeuse. So thank you everybody who voted this week. This was a tough one, and I know people were really torn on which one they should vote for. So, but in the end, you were forced to vote. This is how it works. So we will post the vote for this week's episode into the post tab here on our YouTube channel. But of course, if you want to participate, the best thing to do is subscribe to the channel, click on the notifications bell, and then just obey the algorithm. Tell it that you want to vote early and often. We have stellar mass black holes, we have supermassive black holes, and we even have intermediate mass black holes, the ones in between the two. But you can't get a black hole that is smaller than a couple of times the mass of the sun, because just the laws of physics work this way in the universe, and you just can't get that mass of a black hole. But astronomers have proposed that you could get black holes that formed at the very beginning of the universe, shortly after the Big Bang. And these are called primordial black holes. And they would essentially just be formed by over densities in the initial cosmos. And then there's no limits. You can have black holes with the mass of your house. You can have black holes with 1,000,000 times the mass of the sun. As long as there's enough of a density, you could get these primordial black holes. They can then help explain a lot of mysteries in the universe. For example, they could explain dark matter. That instead of having some weird hypothetical particle, or that gravity doesn't work the way we think it does, there's just a lot of black holes, and they would perfectly explain dark matter. But there's another mystery that these primordial black holes could explain, and that is, how did supermassive black holes get so big so early in the universe? And actually last week we talked about this idea of direct collapse, that if you have to wait for a star to grow, it to go supernova, it to find another black hole, those to merge together, black hole to feed, it's really hard to get a black hole as big as we see. And yet we see big black holes. And so one possibility, they're just collapsing directly into gigantic black holes. But the other possibility is that they had a head start, that a primordial black hole started right at the very beginning of the universe, slurping up material. And so it was able to grow earlier than the process would originally be expected. So in a new paper, astronomers think that you could explain some of the behavior of early quasars by the presence of primordial black holes that were starting to feed on material. A quasar is an actively feeding supermassive black hole, and they go through this change in brightness as more material is available to them, and then less material is available to them, and eventually they quiet down and they become something called a radio galaxy. And so in this new paper, astronomers propose that you could explain these changes in brightness, this switch over into a radio galaxy, sort of mathematical formula that these early quasars follow, by a seed of a primordial black hole. They make another really interesting proposal, is that these early quasars could act as standard candles. Similar to Cepheid variables, you could calculate the intrinsic brightness of the quasar based on the changes in brightness over time. And so you could have a way to measure distances in the universe far beyond the current distance ladder. And so you would have an explanation for early quasars, and you would get a new, very good rung on the cosmological distance ladder. We've got a story about that by Andy Thomaswick. How did life get going on Earth? This is the concept of abiogenesis. And this has always been a challenge. We know that evolution is how we get from one life form to another life form, but where did we get the first life form from? Well, we have all of these organic molecules here on Earth, and so some kind of way that they came together, they turned into the first life form. But it looks like the universe has been giving us a head start. Samples from asteroids have been found with amino acids in them. And in fact, astronomers, when they look out into giant star-forming nebulae, they find the presence of various organic molecules. But the challenge is that as the material comes together and as the star begins to form, it puts out an enormous amount of radiation that then destroys larger molecules. And so you pretty much have a reset. You have to start building up those basic building blocks of life again, once the temperature and the conditions have cooled down to the point that they can come together as molecules again. Well, now astronomers have found the presence of a series of organic molecules in a protoplanetary system that is in this stage of forming planets, heating up, putting out a lot of radiation, that somehow these organic molecules are surviving. And two of the molecules that are really interesting are called ethylene glycol and glycolinitrile. Glycolinitrile is really important because it is a precursor molecule to the various amino acids and molecules that are used by DNA and RNA. And so it looks like maybe all these organic molecules that are appearing out there in the universe don't get torn apart as they go through this protoplanetary system. And then that could help explain how life could have gotten a foothold on Earth as quickly as possible, because the universe was giving us this head start. We've got a story about that by Matt Williams. Europe's ExoMars mission has had a rough go of it. There's been just delays in the mission. And then there was the problem that they had partnered with the Russians to launch the spacecraft. And so that fell through. And then they partnered up with NASA to help launch the mission. And who knows what's going to happen there. So it's been rough, but hopefully the mission is on track to get a 2028 launch, and it's going to have an orbiter, and it's going to deposit the Rosalind Franklin rover down onto the surface of Mars. And it's going to follow the same kind of process as NASA's Perseverance and Curiosity rover. It's going to have an aeroshell, a parachute, and then retro rocket that will land it gently down on the surface of Mars. The shell and parachute have been in storage for a while. And so engineers wanted to make sure that it was still ready to go. And so they recently did a drop test of the parachute for the ExoMars mission. They carried it up to altitude on a giant balloon, something the size of a football field, and then carried it up where the air density on Earth is the same as the atmospheric density on Mars. And then they dropped it, and the parachute worked. And so everything was ready to go. And so at least that's one thing that is no longer a concern. Of course, they're going to have to pack it back up again. Anyway, here's to a 2028 launch to Mars. We've got a story about that by Andy Thomaswick. Wow, Andy is the busy one this week. Now, this was a great collection of space news stories. A banger, I would say. And yet, this is just a fraction of all of the space news stories that we're covering at Universe Today. We dig deep into everything that is breaking across the field. And we report all of this stuff on the Universe Today website. And then I will gather all of these stories together and I will write a newsletter that brings you up to speed on every single one of these. So you can just skim through and find the stories that you find interesting. For example, we've got a story about how ice in space isn't the same as ice on Earth. We've got a story by Carolyn Collins Peterson. How James Webb has found 4 distinct sources for carbon dioxide on Saturn's moons. We've got a story by Lawrence Tugnetti. And how astronomers have found 5 rocky planets around a small red dwarf. It's not TRAPPIST, but it's pretty good. Story by Evan Goff. I write my weekly newsletter on Fridays. It goes up to 72,000 of my closest friends. It's completely free. There's no ads. You can sign up. Go to universetoday.com/newsletter. Do you want even more space news? We have a longer version of this episode with one additional story that we call Space Bites Plus. This week's extra story is about how liquid water could exist on Mars temporarily in brines. I'll put a link in the show notes so you can go and watch that version. Now I'm going to ask you what you're obsessed with. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Barely Griffin, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balick, Cy Nelson, David Gilton, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Monzo, Paul Robeck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Chiplin, Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So as you know, when I conduct an interview with one of the scientists that I'm talking to, I always end with, what are you obsessed with? And this is a hack. This is a way that I get to find out a little bit of the future. I want to know not the results of the research that they've been doing for the last couple of years. I want to know the ideas that are rattling around in their head, some of the really interesting connections that they're starting to make. And I find it's a really productive question. I really enjoy it, and it makes me think, and often leads into a whole other interview as part of the interview. But I want to know what you're obsessed with. What are some of the media trends, the things you're watching, the things you're thinking about, the discoveries that are being made, the software that you're working with, the things that are bothering you, all of that? I would really be interested to hear your version of the "what are you obsessed with" question. Go ahead and put your obsessions down into the comments down below. And I find that really useful because it gives me this direct line with the audience. And often I get to be your avatar. So you are, there's some idea that you're really obsessed with, and I realize, oh yeah, that's something that I'm actually pretty obsessed with too. And then it sits in my brain. And then when I see some paper come out that is related to that topic, I will reach out and try to conduct an interview. So please let me know what you're obsessed with, and hopefully that will be able to turn into more content for you. All right, we'll see you next week.